Hello guys and welcome to Python programming tutorials by Amul's Academy. Today in this tutorial we are discussing about the quicksort algorithm. In this video series we already discussed about the bubble sort and selection sort algorithm. For that I will give you the link in the description box. So now quicksort algorithm is also called as partition exchange sort algorithm. It is developed by Tony Hoare in 1959 and published in 1961. So it is one of the commonly used sorting algorithm. Quicksort algorithm, when implemented well, it can be about 2 or 3 times faster than the merge sort and heap sort. I guess that's why the name quicksort. So quicksort is the comparison sort algorithm. So here also we'll compare the values. To rearrange the list, we'll compare the values. Next, in place algorithm. So that's nothing but it may require small additional amount of memory to perform the sorting, but it is the in place sorting. And next is unstable algorithm. That's nothing but the relative order of equal sort item is not preserved. Like if you are sorting a list and it contains the duplicate values, the order they which appear in the input may not be the same in the output. Okay. So next it is the recursive algorithm. And next, this quicksort is the divide and conquer type of algorithm. So divide and conquer is nothing but in this we'll divide a problem into subproblems, then we'll solve that. Okay. So in the divide and conquer rule there will be 3 steps. First one is divide, second one is conquer, third one is combine. So in the divide step we will divide the problem into subproblems. Okay, so in the case of list we'll divide the list into sublist. In the second step, that is the conquer step, we'll find out the solution for the sublist or subproblem recursively. In the third step, in the combine step, we'll combine the solution for the sublist or subproblem to problem. Okay, so as I said, quicksort also divide and conquer type of algorithm. So in the first step, in the divide step, first we will rearrange the list and we will divide the list based on the pivot element. So pivot element is nothing but a element which will divide the list, and will divide the list in such a way that the elements which are smaller than the pivot element will be present left to the pivot element, and the element which are greater than the pivot element will be present at the right of the pivot element. Okay, so we will rearrange the list and we'll divide our list using pivot element. So how to select pivot element we'll discuss later. And in the second step, in the conquer step, we will find out the solution for the sublist recursively. And here third step is not required in the quicksort algorithm. No need to combine the solution for subproblem to problem. Okay, so we won't do any combining here. So I talked about the pivot element, right? We will divide the list using pivot element. Then what is this and how to select this, right? Pivot element is just an element in the list. Okay, if you ask how to select that, then you can choose the first element as the pivot element, or you can choose the last element of the list as the pivot element, or you can select a random element or median of 3 values, that is first, middle and last. Okay, so if you search for the quicksort algorithm, okay, in Google or YouTube, in the most of the example you can see either first element or the last element is the pivot element. So this is the easiest way to implement. But when sorted list is given or reverse sorted list is given, this is the bad choice, because we'll select minimum or maximum value as the pivot. After partitioning the list, either left side or right side will be completely empty. Okay, so when the sorted list or reverse sorted list is given, this is the bad choice. So in that case we can go for the random element. We can choose random element as the pivot element, or we can go for the median of 3 values. Okay, so the selection of pivot element is very important. It is entirely depend on the type of input. Okay, next we'll take one example. So I took a list called A and these are all the elements. I want to sort them in the ascending order. So for that, the first step in the quicksort algorithm is selecting the pivot element. Okay, so as I said, we can select the last element or first element or random element or median of 3 values. So here first I'll take the last element as my pivot element. Okay, so this is my pivot element. So next step is I need to find out the original place of this pivot element, that is 17. So when I arrange this number in the ascending order, what is the original place of 17? I need to find out it now. So for that, what I need to do is I need to place all the smaller values in the left side of the pivot value, and I want to place all the bigger value to the right side of the pivot value. So to do this, we need to compare all the values with the pivot value. So for that, I need 2 more variables. So here I'll take one variable called left and it will point here. So the first element of the list, and here I'll take next value as right. It will point last but one value, because here last value is pivot value. Here we are comparing the values with the pivot value. So I don't want to compare this 17 with 17. So that's why I took right from here. So I'll take the index 0, 2, 3, 4 and 5. Okay. So right is in 4th index. So now we'll begin from the left. Okay. So we'll start to compare the values with the pivot value. So while comparing the values, we need to follow few rules. Okay, so that is these rules. First one is always the left index value should be less than or equal to right. Okay, if left value become greater than right value, then I need to stop. Okay, here this first condition. And next is if this condition is true, then I need to check the left value, that is the first value, whatever the value present in the left index is less than or equal to pivot value. If this condition becomes false, then I need to stop. And I'll go to the next condition, that is this condition. Okay. Here also I'll check the value present in the right index should be greater than or equal to pivot. If not, then I need to stop. We need to follow these 3 rules. So here first I'll take the left value. So now initially left value is 0 and right value is 4, right? So I'll write down that. So now first I'll check the first condition, whether left is less than or equal to right. Yes, because left value is 0, right value is 4 and 0 is less than 4. Okay, so I can go for the next condition. So here the next condition is I need to check the first value which is present in the left index, whether it is less than or equal to pivot value. That is nothing but I need to check whether 14 is less than or equal to 17. Okay. If this condition is true, then no need to do anything. I need to move to the next value. I need to compare next value with the pivot because I want smaller value in the left side. Okay. If it is become false, then I need to stop. Okay. And here in this case we can see 14 is less than 17. Okay, so this condition become true. So what I need to do, go to the next value and compare that with the pivot value. Okay, so now this will be my left value. Here left index become 1. So now I'll check whether 25 is less than or equal to 17. Okay, so if it is true, move to the next value, not stop. We can see 25 is greater than 17. Okay, so this condition become false, so I need to stop here. So here I'll stop that. Okay, so now I'll move to this right condition. So here in the right, first I'll check whether left is less than or equal to right. Yes, it is, because 1 is less than 4. Okay, so next I'll go to the right condition, that is this condition. Okay, so here the value present in the right index should be greater than or equal to pivot value. Okay, so I'll check A of right, the value present in the right index is greater than or equal to 17. So here first we can see the value is 1. So 1 is greater than or equal to 17. If true, then move to the next value. False, stop. So it is false, right? Because 1 is less than 17. It is not greater than 17. So I need to stop here. Okay. So in the left side we stopped for a value because we got a value which is greater than the pivot value. In the right side we got a value which is less than the pivot value. Now what we need to do? We need to swap the value present in the left index and right index, because here we want all the smaller number in the left side, all the bigger number in the right side. Okay, so that's why we need to swap them now. So I'll swap 1 and 25. So 1 will come here and 25 will go here. Okay, now again we need to check from the beginning. So here we'll start from the left side. So first here we can see the value 1. So I'll check whether 1 is smaller than or equal to 17. Yes. If yes, then I need to move towards the next value, right? So left will point here now. Here left value become 2. Okay. So now again I'll check whether the value present in the left index is smaller than or equal to pivot value. No, it is not, because 100 is greater than 17, right? So I need to stop here and I'll move to the right side. So I'll check whether 25 is greater than or equal to 17. Yes, it is. So I'll go to the next value. Okay. So right will point here now. So right value become 3 now. Okay. So now I'll check whether this value is greater than or equal to pivot value. 14 is greater than or equal to pivot value. No, it is not. Here this value 14 is smaller than 70. So I need to stop. So now we got the two values. In the left side we got a value which is greater than the pivot value, and in the right side we got a value which is smaller than the pivot value. So I need to swap 114 now. So the value present in the left index and right index. So 14 will come here and 100 will go here. Okay. So now again we'll start from the beginning. We'll check whether left is less than or equal to right. So before checking each value with the pivot value, you need to check this condition. Okay. Left should be less than or equal to right. Here it is true because left value is 2, right value is 3. So left is less than right now. So I'll check whether 14 is less than or equal to 17. Yes, it is. So I'll move to the next value. So now left will point here. So now I need to check whether 100 is less than or equal to 17. No, it is not, right? 100 is the bigger value. So I need to stop here. Here I am stopping this left index. Now I'll move to the right. Here left index is 3 now. So before checking the right value, I need to check whether left is less than or equal to right. Here left and right are equal. Both are 3 now. Okay, that's okay. The condition is true now. So it will check whether 100 is greater than or equal to 17. Yes, it is, right? 100 is a greater value. So I need to move to the next value. So right will move to this value. So now right become 2. Okay, so next, to check the next condition whether 14 is greater than 17, I need to first check this condition, that is whether left is less than or equal to right. No, it is. Left become greater than right. Left value is 3, right value is 2. Okay, so if this happens, I need to stop everything. Okay, now I need to stop. When the left value crosses the right value, that means we got the actual position of pivot value now. So to place that in the correct position, we need to do is we need to swap now, okay, pivot value and the value present in the left index. Okay, so why? Because when we take last element as the pivot element, okay, so then we need to swap pivot and left index. If you take first element as the pivot, okay, if you take first element as pivot, then in that case you need to swap pivot and the value present in the right index. Okay, you need to remember this. Here we took the last value of list as the pivot value. Here we can see, that's why I need to swap pivot and left index value. Here left index value is 100 and pivot is 17, so I need to swap these two. Okay, so here we got the original position of the pivot value, that is 17. So that is nothing but 17 is sorted here now. 17 is present in its correct position. That's nothing but if I sort this number in the ascending order like 1, 14, 14, 17, 25, 100, right? This is the correct order. So if I take 0, 1, 2, 3, 17 should be present in the third index. So here we can say it is present. That means 17 is sorted. This is not sorted and this is not sorted. The elements present left side and right side of the pivot element is not sorted, but 17 is sorted here now. Okay, so based on that now we will sort all the other elements also. Here if you observe, then we can see the element which are present in the left side of 17 are smaller values, and the elements which are present in the right side of the pivot value are the greater than the pivot value, right? So now what we need to do is we need to divide the list. So as I said, it is based on the divide and conquer method. So here we'll divide the list based on this pivot element. Okay, so here we need to divide like this. First is 14 and 1 and 14. Okay, this is one sublist. Next is 25 and 100. Okay, here 17 is sorted, right? So we need to solve this sublist separately. So we'll apply same method. Okay, we'll take the last element as the pivot and we'll search the correct position of that pivot element. So we'll repeat the same step. So we'll do this recursively. Okay, so here we'll take 14 as the pivot value now. So this will be left value, this will be right value, right? So first I'll check whether 14 is less than or equal to 14. That is, this value is less than or equal to 14. Yes, it is. So I'll move to one position next. So now left will point here. So again I'll check whether 1 is less than or equal to 14. Yes, it is true. So again I'll move to the next value. So it will point here. So now here we can see left value is crossed the right value. Here right value is 1, left value is 2. So left is greater than right. So I need to stop. Now I need to swap the value present in the left index and pivot value, right? So both are same here because left index value is also 14 and the pivot value is also same. So we need to swap 14 with the 14. So we'll get 14 only. So here we'll get the same list. Okay, so if I divide this list now based on this pivot value, then we'll get 14 and 1. We'll get only one sublist because here there are no elements present at the right of the pivot element, right? So we'll get this sublist. So now again we need to find out the same method, that is I need to take the last element as the pivot and I need to find out the original position of that pivot element, then I need to divide the list. Okay, so here 1 is the pivot value. So this will be left and this will be right because only two values are present, right? So this is the pivot value. So first I'll check whether 14 is less than or equal to 1. No, it is not, right? 14 is greater than 1. So I'll stop that and I'll go to the right side. I'll check whether 14 is greater than or equal to 1. Yes, it is, right? 14 is greater than 1. So I need to move to the right towards the next value. So here, right will point towards here. So -1 index. Okay. So now we can see the left value is greater than right. Right value is -1, left value is 0. So left is greater than right. So I need to stop and I need to swap the value present in the left index and pivot. Okay, that is nothing but I need to swap 14 and 1. Okay, here if I swap that, it will become 1 and 14, right? So here 1 was the pivot value. So if we divide this, we will get a single list called 14 which contains only one element. Okay, so if a single element is present, that means it is sorted, right? So it will return 14 here. So we'll get 1 and 14. This will return to here. As I said, we'll do this operation recursively, so it will return the result to the previous function. So this result will be returned to here. So this is nothing but this part is sorted and we'll get 1, 14 and 14 and 17 because 17 is also sorted. We'll get this now. Okay, so next we will move to the next. So we will move here. So here first I'll take 100 as the pivot value, and this is left and this is right, and I'll check whether left 25 is less than or equal to 100. Yes, it is true. So left will move here. So now left comes here. So now we can see right value is less than left value. So we need to swap, and I need to swap 100 with the 100 because 100 is pivot value as well as the value present in the left index. So I need to swap 100 and 100. So this is the pivot value. So it will return the result as 25. Okay. So this is pivot value. That means it will return the sublist that contains only one element, that is 25. So this function will return 25 and 100. So we'll get 25 and 100 only. It is sorted. So now all the elements are sorted, and here we can see the final result. It is 1, 14, 14, 17, 25 and 100. All the elements are in ascending order. Okay, so this is about the quicksort algorithm, how to arrange the numbers in the ascending order by taking the last value as pivot value. So now I'll stop this video, and in the next tutorial we will see how to sort the numbers in the descending order, as well as how to take first element, random element and median of 3 values as the pivot value, and how to arrange the numbers. Okay. So thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.